Hello, everybody. Um, I would like to make a few explanations about this little design assignment that we have. So, um, not quite sure. Here we go. Screen. So the assignment is to make a welded version of this workpiece here, which we called housing in the last assignment. And the original design is a piece made from solid material, so machined from solid material. And the assignment here is to replace this with a welded groove using three different components, but one of these components twice. So why would anyone do that? Normally, it depends on the size of the workpiece. Mostly, it's of course to reduce the overall cost of the part by two ways. First of all, you're using less raw materials. Second, you need to do less machining. That's of course not always the case. This example workpiece here is a bit small, but I still think this example can make the point that I just made. So normally, if you would machine this, you would need a raw piece of the dimensions of 150, or actually a bit more probably, by 100 by 100. Here you see it, right? So that's not a very big workpiece, but it's still, if it's made from steel, about 12 kilograms of steel, I would estimate. And then you have to machine all this stuff from the sides, and you have to machine this core piece. That's a lot of work. So you'd be spending a lot of time and effort and money making this piece. Now, if you make this from or as a welded group, you can make the main part of the housing, the centerpiece of the housing, from a tube material. Of course, you need to find available raw material, a tube that is a bit smaller than the minimum dimension here and large enough for the outer dimension that you need. But then the effort of making this central housing, including the bearing seats we have inside, would be a lot less. And actually, if you cut all this internal geometry on a turning lathe, it's actually easier to achieve the tolerances that we need to achieve. Functionally, we need the bottom surface here. This is obviously some sort of mounting flange, right? So the bottom surface is needed. And this is a flat surface, so we can replace this with a flat piece. And then we just have to somehow get that tube part onto the bottom part. And it looks like you can just easily weld it on top of it, but it's way more elegant if you use like vertical walls, maybe at the back and the front. And this is exactly the structure that I suggested in the assignment. So this would be it more or less. So you see, I have a bottom plate. If we look at that separately, you see those two cutouts, and I will explain them in a second. This would be the wall, which we need two times, and it has the counterpart to these cutouts in the floor part or the mounting flange part. So they can lock into each other. And then finally, this is the main part. This would be the cylindrical housing. So if I highlight it, you see it has the internal geometry. And you can also see it has at the ends, right here where my mouse should be. I'm not sure you can see that in the shared screen. So it has these little recesses, these little cutouts here, so it can lock into the two walls. So generally, that's a good idea for a welded group, is that the parts actually lock into each other. You still need to clamp them before you weld them. But if you already have form features that position the parts to each other, that's definitely uh, that will produce better results with regards to the overall accuracy of the finished part. Okay, so see that? I think that's kind of clear what we're looking at now. With regards to the design process, if I make a replacement of a part, I put the original part into into the same assembly. Later, I can delete it, but that allows me to directly compare everything. And you see that the bottom surface is identical. The overall width is identical. But not everything is identical here, as I'm only using 5 mm plate or sheet material. The original housing has thicker feet, but that's not necessary. And of course, instead of this big, massive block of material here, we have this structure, and it's going to be a lot lighter, and we'll have to pay less for the raw material, because normally when we buy steel or any material, mostly we pay per kilogram, right? So so that's basically it. It can the parts can be locked together, then they can you can use additional clamps, and then you can weld. So I've I've advised you generally and specifically for this assignment to strive for a design that allows you to use fillet welds. So you need corners between, I call them corners between the parts that you can weld, that you can place your fillets into. And of course, you also have to keep in mind that you need to get to the space where you weld, and the actual weld seam will need some space. So this design is not yet perfect. So you can imagine placing weld seams here to connect the floor with the walls, and it seems you can put a nice fillet weld here inside between the walls and this housing bushing, whatever that's called. But then if you look down here, this weld seam would not allow placing the floor part against it. There would be a collision between the weld seam here. So either you do not weld all around, right? Or actually, when you assemble it before you start welding, you wouldn't even be able to weld all around, but you might have some sort of undefined weld crossing here. And definitely, probably you can't even weld into that gap, right? So it's not a perfect situation. Welding on the outside is possible only with V-butt welds. So you would have to prepare these parts. You would have to put chamfers on the hole. Then you could place a V-butt weld here. Same here in this contact. You could take these edges away to weld these two parts together with a V-butt weld. But it's a lot more work. And I've in the assignment, I've definitely asked you to try to design it in a way that allows for using only fillet welds. So how can we achieve that here? I have the idea that I move these two walls slightly inward, then I would be able to weld wall and floor on the outside with short fillet welds, and then I could place a fillet weld between the tube and the wall on the outside. It's much easier to get there. It's much more accessible. It will look a bit more awkward than it does now, but I'll give it a try now. So what I'll have to do is I have to increase the depth of these cutouts here. Currently, they're just thick enough to accommodate the 5 mm sheet. I will make that 10, and I have to do the same thing. So you see that the cutout is deeper already, but I would have to do the same thing with this tube. So you see it has, I pointed that out, it has these cutouts on the outside. And there should be a dimension here somewhere. There it is. So I'll change that from 5 to 10. And by the way, just to show you my process, I'm a really lazy person. That is actually a copy of the original model, my original design. And so I copied the file, gave it a new name, and then I just rotated all the material off. Only one more step to make this new part from the old part. Now, if you go back into the assembly, the position of the two outer walls hasn't changed yet because I need to regenerate the model first. And now you can imagine, if you fully understand what we've been discussing, that now you can place a nice fillet weld on the outside to connect this tube-shaped housing with the two walls. And it's also possible to place a weld seam here to connect the walls with the floor. And to some degree, if you want a double-sided weld, but this would have to, you would have to define the length of that. That could happen right here. Okay, so that's pretty clear. I think before we start actually welding, I would like to start the drawing on that. I haven't tried it myself yet. So you know what I always do? I just pretend I want to rename the file, but I actually only copy the file name and then set up the drawing. And I like to use a drawing format. And I'm using a different drawing format than you should use. You should use the one with the MESD file title block with the MESD logo in there. I just use that one, which is basically the same, though it uses a different logo. And now let's see. At least want to have. Let's see what it. I don't know what the views are called yet. Anyhow, so let's switch. Why can't I see my planes? That's weird. No, I can see them. So I'll put the front view. So that's one view. This is going to be a section view later on, so I can see the inside of the tube. And it's quite a small part. So as I expected, it should be possible to have three views of this in the drawing. Although now the length, that still fits beautifully. Beautifully. So that should be enough to show us all the dimensions and the welding symbols. Although I can already transform this into a section view. Just a simple plain section called A, and it goes through the front view, and that should be it. Why do we have this weird double hatch? I guess because it's an assembly. So what I will do is I'll just this is 2 millimeters. Maybe I need less. 1.5. Okay. Go to the next section. So what I'm doing now is I'm just stepping. So obviously, for some reason, this part has two hatch lines because I used it. I don't know. Maybe because I used it in a different assembly. So it has. So I'll just delete one line, and then this line should have an angle of 135 and a spacing of, let's say, 2 millimeters. Next is the floor part. That's not so great. Doesn't matter. Angle 45, spacing 2. It has to be slightly different than the wall part. See, it actually looks different. So there's no hedge here at all. I wonder why that is. I guess because the spacing here is just a very large value. That's correct. So it just slipped out, and then I can use an angle of 135. Done. So that's good already. We can already think about maybe the dimensions and the axes. Just that's repeat, you know that already. So I can just already just show all the dimensions of this. Some of them I won't need, but I can delete them later on. And then the axes. I think I only need 3 of these. That's a good start. I think this one I can already erase. Erase this one. This is my lazy rotational cut that I used. Outside diameters, and so these dimensions definitely are not needed. And the other stuff I can take care of later on. I think I don't need to discuss that too much. But what I do need to discuss is how we put the weld symbols in there. So I'll say that first. And you should remember from class that putting in the weld symbols into the drawing and actually also a visual representation of these is done by first modeling the weldings. And for this, we have to open a different application inside of the assembly model. I didn't point it out, but it should be clear by now that in order to model a welded group, we model the parts as separate parts, and then we create an assembly, which we've done many times before. We assemble the components, and after we've placed them all, we add the weldings by starting the application welding. And then I prefer to only use the most simple welds if possible. So I indicated that already. I will use the fillet weld menu exclusively. And the way it works, first we need to give a dimension to the weld seams. So normally they have to be chosen with regards to how thick is the material that we're welding. I pretend we can do at only 3 mm fillet weld here, and then we choose one side first. Let's weld the floor part with the walls. We can do that in one feature. So I go in here, and then I select this wall, and immediately, this is because of my cutout. This is a nice side effect. We get both sides immediately. And if I hold down the control button and select this, we also get the weld seams here. Now, if I select the other side, it will give me a nasty. I can actually show that. So it interrupts the weld seam because it recognizes it can't go under the tube, but it's not nice because it's undefined. Nobody really wants to weld down here. So I would rather not do that. I would probably be a bit lazy and just weld it on a single side. It's better to weld on both sides to avoid for distortions, but it can't really distort here anyway because the tube is keeping the walls separately. So I pretend this is good enough. And you see the orange surfaces, these are the little symbols that just visualize the weld seams. And I will do this one more time to weld the walls with that central main housing. Again, enter a value, 3 mm, A, and I can do both at the same time. So I just say, okay, this flange or cylindrical surface of this part is side 1. And now I can select the other side. And you see here, because of that cutout and everything, the weld seams do not intersect, which is always a good idea. So now everything is connected with everything well enough, not too much welding. I think this is a nice clean solution. We only have, well, actually these are interrupted. So for the welder, this would be 1, 2, 3, 4, 5, 6, weldments, but because I created this as only one feature, I will have only one symbol for that in my drawing. And I believe that's good enough in this case. So now you see the representation of the fillet welds. This is a bit ugly in Creo. The problem here is that these little surfaces are shown even if they shouldn't be shown because they should be hidden. In my older version, this is kind of a bug, but generally, if you have a view, if you want to make sure that the weldings are only shown where they should be visible, you should do this here. Hidden line removal for quilts, yes. So in view display menu of that view, you should do that. And now it looks, maybe you can't tell the difference, but now it shows only the symbols on one side. Let's check if I can do that. Well, yeah, that looks a bit better. Now the problem here is I would really like to hide these welds that go around the cylinder, but I know from experience that I can't hide them. I don't know why this menu is great here. Obviously, the software can't do it. That is just a bug in my older version. Maybe in your newer version, it works well enough. So let's just ignore that. And then the weld symbols. I wonder if I can show them. I can. You find this in the is it actually? Yeah, it's called show model annotation. So there's this little tab, the one before the axis, and that allows you to use these. So I mentioned it already. This is not super great because it includes a lot of information that we don't always need. But it's good enough. I don't expect you to become a professional expert immediately. So you can just use this default symbol with all this extra information. It's not that much information, and it gives us the total length, which it calculated. So that is this round seam around the cylinder is quite long, more than half a meter. It automatically puts the all-around symbol on there. I didn't do that. And it gives us the dimension of the weld seam itself, A-type dimension 3 millimeters. This just means number 2. It's not really that much info, but it's kind of messy. So that's it actually. If you want to submit this assignment, of course, fill in the title block as we always do. Clean up the dimensions. I said include all the dimensions. That is not as much work as it seems, right? Just basically we need the dimensions of the inner cutouts for the bearing seats, total length, total width, total height, position of the axis relative to the floor, as we have in the assignment, right? So the 100 overall, 50 top from axis, we have 100 wide and 150 wide, and then 100 millimeter deep, the dimensions of the bearing seats, which are individual to each student. And it's not so much. So there you go. So I hope this helps with with this assignment. If you want to submit it, I would advise anyone to at least think about it before the exam, even if we don't use CAD in the exam, but it is still an interesting example. So check it out, even if you don't plan to submit this assignment, because as I've informed you in written form, I planned at the beginning of the semester to have 4 assignments. I only gave you 3 because you seemed to be a bit overwhelmed. So I decided that if you want to do the 4th assignment, great. But if it seems to be just too much for you, I will calculate a score as an average from your first three assignments. Now, if you have 10, 10, and 10 points already, you wouldn't uh, really benefit from submitting the fourth one. But let's say you didn't do so well in the first three assignments, you can collect a few extra points by doing this if you do it perfectly. And that's all of that for today. And I wish you, um, well, health and good concentration for the upcoming 2 weeks. Bye bye.